everybody. How are you doing? I wanted to start off with a question. Who here in the audience has flown in an electric aircraft before? No one, just me. That's not so strange because there only is one certified battery electric aircraft, a two-passenger plane from actually designed in Slovenia by Pipistrel. I imagine that if I'm back here in 10 years, maybe half, maybe more of you will have flown in an electric aircraft, and it's pretty exciting. So I want to tell you a little bit about what we're doing and how aviation is electrifying and how a lot more is possible within that, and how we're working on that. Let me see if this works. Yeah. So let's take a little look at the industry of today. While a lot of the incumbent industry has been working on solutions to decarbonize aviation, recently a lot of them have also been announcing delays, pushbacks, and been talking a lot about challenges in the press. From Airbus delaying their hydrogen technology platform by 5 to 10 years, from airlines kind of going backwards into and readjusting their net zero targets, and IATA talking about that publicly. The challenges around, for example, meeting soft targets, and the new single aisle from Airbus, basically the biggest new aircraft development in the next few years, not really containing any new powertrain. Obviously, there will be some fuel consumption reduction, but they're not really radical changes that we're looking for, and big innovation. What we do know is that there is a massive problem in aviation, and the part of aviation in terms of the total global emissions is growing. I'll touch on that a little bit. We do think there is a solution, and it has been overlooked. And there's good reason why it's been overlooked, but we found a way to actually commercially fly electrically and it becoming economically viable. While the industry is not really taking action, there is an opportunity to actually, step into that void. And of course, aviation is a very difficult industry. There are not many players that are able to certify technology for aerospace, and we feel we have a very good history and track record. We come from a good place to be able to make a difference there. So what if you could actually save energy by flying electrically that is the equivalent of 100 million electric vehicles, or the equivalent of 55 million households? You could power 55 million households. Or for the software startups here, 320,000 data centers. That's huge, right? And you probably would do that. And we believe that with the E9X, you can. There is the potential to do that and do things in a more efficient way. And that is to say, by 2040, we believe theoretically, the technology that we've developed allows for half the world's flights to be fully zero emission. With that, it's the cleanest option, and we've done research on that, which I will show. But it's also the most economically interesting option. You can actually compete per passenger with the leading aircraft of today. And a huge amount of energy can be saved annually. Let's quickly look at the emissions problem in aviation. I think for many this will be known, but by most estimates this is going to grow to over 1/5 of total emissions, just because it's so hard to decarbonize aviation, and there are so few solutions that really make a difference at scale. If you could sort of double click on that, as I said, half the world's flights are under 1,000 kilometers, so aviation is surprisingly local. A lot of people fly short distances back and forth. And a lot of it is sort of concentrated there on the left, short distances, city pairs, and what is also surprising is that those distances are often flown by large planes, narrow bodies, so the Boeing 737s, the Airbus A320s, mostly driven by cost for airlines. So sustainable aviation fuels has gotten a lot of attention and is of course a very clear path to immediate decarbonization. Supply being there, assuming supply is there. Because it's drop-in, you don't need to change the aircraft, but we see major constraints. There are constraints in supply, So feedstock is not widely available. It needs to be used for many different applications. And e-fuels are still scaling up. So 10 years ago, it was the expectation that by now we'd be at 10%. We're under 1%. So things are not moving very quickly. And one of the major problems is price. SAFs are very expensive, 8 to 10 times more expensive or 12 times even for e-fuels. And by most estimates, they might drop down to 3 to 5 times. But it's not looking super good from a price perspective for the airline. So our message is, if you can electrify, you should electrify. And you see that sort of across the board. Also the interesting presentation that touched on mining before. Most of the benefits are in the costs, in the maintenance, the fact that you don't have non-CO2 effects, which are significant. They're under-researched, but they can add another 10% or so in terms of climate impact. Noise is easier to tackle, and there is supply. Of course, we have to deal with grid congestion, but it's about efficiency here. And that's also what we show here. So, it's very simple. By electrifying, you retain about 80% of the energy versus less than 20% for the other technologies. So, again, where something can be electrified, it will. And you see that across all industries, and aviation is next. The problem was, because of the weight of batteries, people thought, and this was also the academic world and industry experts, that you could never fly a significant range with an aircraft because of the weight of batteries. And we found a solution to circumvent that. So then touching on what we've developed, we've actually done research for 3 years, totally under the radar in stealth mode, because we wanted to be absolutely sure that what we found was correct. And because, of course, when you start claiming you can fly 800 kilometers on batteries, you need to have solid scientific backing because nobody will believe you. So we did 2 pieces of research. One was about why the reasons people thought this would never be possible were wrong, what was overlooked, and then what the optimal design would be. And that's how we came up with the E9X. So the first aircraft that can fly a really significant range, about 500 miles, 800 kilometers, with a 90-passenger payload. It looks pretty traditional, but it has a very wide, heavy wing, fully stacked with batteries, a fuselage, so a body about the size of a regional jet. The wing is about the size of let's say, an Airbus A320. 8 engines, and a backup system only used for reserves. So that's how we make sure we don't use our battery for reserves. We did some research, as I mentioned before, on how does this stack up in the life cycle across not only other aircraft technologies, but also other transport forms. And the results even surprised us by a lot. So our E9X per passenger per kilometer in CO2 equivalent beats all other aircraft technologies from SAF to H2, but it also can beat electric train, considering the amount of infrastructure that is needed and stacking that up against the production of the aircraft and batteries, etc. So this is a very ecologically friendly transportation form, and for that reason it has a ton of potential even outside of aviation. Then there is also the economic argument. So the economic argument is that, and I discussed the SAF prices before, with a doubling of energy cost, whether that's because of SAF mixing or charges, we actually don't just beat the regional aircraft in terms of operational cost, but also the narrow bodies, so the most profitable planes in history. And then you got an economic argument for airlines to use this plane rather than only an ecological one. So battery technology is obviously always the elephant in the room. Battery technology won't be there, batteries are too heavy. Actually, with battery technology of today, we can already fly 500 kilometers. So our plane is really based on solid aerospace designing principles and a new way of looking at that. We are targeting an 800-kilometer initial range that are entering into service in 2033. But if it ends up being somewhere between 600 and 700, we still have a good business case, and this is feasible with minor improvements in current battery technology. So this can happen either way, and the business case is good. It just can only get better. And very important is we are building a modularity into the plane that with every battery swap, which needs to happen once a year, an airline can upgrade its range by just putting in new batteries into the plane. We have a very strong market fit because of the reason I mentioned. A lot of these flights happen at these ranges, and actually the top airline brands fly surprisingly local as well. We have worked from day one with some key airline partners and are now expanding this. As I said, because so many people didn't think it was possible, we are really the only one, and we have a patented technology regarding this. And I can talk about charging maybe separately if somebody is interested, but this is not a very big hurdle. We've actually done research on this, and the investment needed and the power needed are pretty manageable. It's not so much a technical problem as more an economic and political challenge. Our timeline is now going into component and configuration testing and aiming for entry into service into 2033. And we are currently raising a Series A of up to 40 million, for which we will actually build these demonstrators and further show the feasibility of this project. So thank you very much for your attention, and that was my presentation.